Topic 3.5 Application of Determinants. You will learn two applications of determinant. The first one is adjoint method. Adjoint method here we will use to evaluate the inverse of a matrix. So the inverse of a matrix can be computed by using adjoint method. Then the formula will be A inverse equal to 1 over determinant of A, and then you multiply with adjoint of A, where adjoint of A here equal to cofactor of A, and then we transpose it. So what is CA? CA here is C11, C12, C13, C21, C22, C23, C31, C32, C33. So after you find all the cofactor for each entry here, and then you transpose it, you will get adjoint of A. For example, here I use A as a 3 by 3 matrix. So when you transpose it, you will get C11, C21, C31, C12, C22, C32, C13, C23, C33. That's how you get adjoint of A. Alright? So remember here, when you want to find the inverse of A, you need to find two things here. First, determinant of A, and then the second one is adjoint of A. So after that, you can solve A inverse by using adjoint method. Let's solve example page number 59. So you need to find the inverse of A using adjoint method. So this one, the given matrix A. So remember, formula for the adjoint method is 1 over determinant of A, and then we multiply with the adjoint of A. So first, I will find adjoint of A. So the formula for adjoint of A equal to cofactor of A. That means we need to find the cofactor of A, and then we transpose it. So cofactor of A is C11, C12, C13, because our matrix here is 3 by 3 matrix. So the cofactor will be C11, C12, C13, C21, C22, C23, C31, C32, C33, and then we transpose the cofactor here. So we need to find each of C11, C12 until C33. So first I will find C11. C11 here, remember the formula to find the cofactor, negative 1 power 1 plus 1. 1 plus 1 here. And then you need to find the minor of M11. So negative 1, 1 plus 1 equal to 2. And the minor here, we check the matrix A here. This one minor of matrix A here. So that means you delete first row and first column. So the matrix that you will have here is 6, 3, negative 4, 0. You only left with this entry. So you solve this one to get the cofactor of C11. So negative 1 power 2 is 1. And then we compute the determinant for this one. So determinant for this one equal to 0 multiply with 6 minus 3 multiply with negative 4. So 0 multiply with 6, you will get 0 minus 3 multiply with negative 4, negative 12. So this one you will have positive 12. 0 plus 12, you will get 12. So C11 here equal to 12. Next, we find C12. So equal to negative 1, 1 plus 2, 3, and then M12. So negative 1 power 3, negative 1, M12, we delete first row, second column. So you only get this entry, 1, 3, 2, 0. So negative 1. Okay, so the determinant for this one, 1 multiply with 0, 1 multiply with 0 minus 3 multiply with 2. So we solve for this one. 1 multiply with 0, you will get 0. 3 multiply with 2, so minus 6. So negative 1, 0 minus 6, negative 6. So equal to 6 for C12. Next, we compute C13. So C13 equal to negative 1 power 4 and 1, 3 equal to negative 1 power 4 equal to 1 and 1, 3. So you delete first row, third column. So you only left with this entry, 1, 6, 2, negative 4 equal to, so we compute the determinant for this one, 1 multiply with negative 4 minus 6 multiply with 2 equal to 1 multiply with negative 4 minus 12. So negative 4 minus 12, you will get negative 16. So you will get C13 equal to negative 16. Next, C21 equal to negative 1 power 3, 2 plus 1, and 2, 1. Negative 1 power 3 equal to negative 1, and 2, 1. So we delete second row, first column. Second row, first column. So you only left with 2, negative 1, negative 4, 0. Okay, so same thing here. We find the determinant for this one. 2 multiply with 0 minus negative 1 multiply with negative 4. So we compute this one, negative 1, and this one, 0. 2 multiply with 0, you will get 0. So negative, negative, positive, positive, negative, negative 4. Minus 4. So negative 1, 0 minus 4 equal to negative 4. So this one you will get positive 4. Next, we compute C22. So same thing here. Negative 1, power 4, 2 plus 2, and 2, 2. equal to negative 1 power 4 equal to 1. So M22 second row, second column. So we delete second row, second column. So you will get here 3, negative 1, 2, 0. And then we solve this one. And then we compute the determinant for this one. 3 multiply with 0 minus negative 1 multiply with 2. So this one you will get 3 multiply with 0, 0. So negative, negative, positive. 1 multiply with 2 equal to 2. So 0 plus 2 equal to 2. So 1 multiply with 2, you will get 2. The next one, C23. We do it the same thing here. Negative 1 power 5 M23 equal to negative 1 power 5, negative 1 M23, second row, third column. Second row, third column. So you will left with 3, 2, 2, negative 4. So this one, negative 1. Determinant for this one, 3 multiply with negative 4 minus 2 multiply with 2. So what you will get here, negative 1. 3 multiply with negative 4, negative 12 minus 2 multiply with 2, 4. So negative 1, this one negative 16. So negative, negative will be positive. So you will get here positive 16. Next, C31 equal to negative 1 power 3 plus 1, 4 M31 equal to negative 1 power 4, 1 M31. We delete third row, first column. Third row, first column. So 2, negative 1, 6, 3. So we solve for this one. Determinant for this matrix here, 2 multiply with 3 minus negative 1 multiply with 6. And then what you will get here, 3 multiply with 2, 6. Negative, negative will be positive. 1 multiply with 6, 6. So 6 plus 6, 12. So 1 multiply with 12, you will get here 12. Alright, next, C32 equal to negative 1 power 5, 3 plus 2, M32 equal to negative 1 power 5, negative 1, M32. We delete third row, second column. Third row, second column. So you will only left with 3, negative 1, 1, 3. So we compute, we solve to get C32. So 3 multiply with 3 minus negative 1 multiply with 1. So negative 1, 3 multiply with 3 equal to 9, minus minus will be positive. 1 multiply with 1 equal to 1. So negative 1, 9 plus 1 equal to 10. So negative 1 multiply with 10, you will get here negative 10. Okay, the last one, we compute C33. So equal to negative 1 power 6 and 3 equal to negative 1 power 6, you will get here 1 M33, delete third row, third column. Third row, third column. So you will get here 3, 2, 1, 6. So we solve here. What you will get for the C33? So this one 3 multiply with 6 minus 2 multiply with 1. And then 3 multiply with 6, 18 minus 2. So 18 minus 2, you will get 16. 1 multiply with 16, you will get here 16 for C33. After we get all the cofactor for the matrix A here, so you can get here what is the adjoint of A. So adjoint of A here equal to cofactor of A, and then we transpose it. So we know just now cofactor of A equal to C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, then this one we need to transpose it. So you substitute all the value for C11, C12 up to C33. So C11 here equal to 12, C12 6, C13 negative 16, this one 4, 2, 16, 12, negative 10, 16. And then we transpose this one. So then, what is the adjoint of A here? So you transpose this matrix, you will get 12, 4, 12. Interchanging. Row become column, column become rows. So 6, 2, negative 10, negative 16, 16, 16. Remember, transpose means that you interchanging between rows and column. After we get adjoint of A, next we need to solve for the determinant of A. So determinant of A, I will use a cofactor expansion. You can choose any rows or column. Okay, let's say here I choose third column. So that's means the formula for determinant along the third column will be A13 C13 plus A23 C23 plus A33 C33. So then you substitute all the value for A and C here. So A13 equal to negative 1 and C13 we have it already. So you can check here. C13 equal to negative 16. So A23, so we go back here for the matrix A. So A23 equal to 3. So this one will be 3. What is our C23? C23 here is 16. So you multiply with 16 plus A33. So A33 here is 0. And what is C33? 16. So what you will get here? Negative 1 multiply with negative 16. You will get here 16 plus 3 multiply with 16. What you will get? 3 multiply with 16. You will get here 48. Plus 0 multiply with 16. You will get 0. So you add these two. 16 plus 48, you will get here 64. So the determinant of A will be 64. Okay, then the last one, we can compute the inverse of A using the adjoint method. Okay, so this one, the formula, remember 1 over determinant of A multiply with the adjoint of A. So 1 over 64. And then, what is the adjoint of A? This one. We get just now. So, you write it here. Negative 10. Negative 16. 16. 16. And then, we just do the multiplication here, scalar multiplication. 1 over 64 will multiply with this matrix. So what you will get here, this one 3 over 16, 1 over 16, 3 over 16, 3 over 32, 1 over 32, negative 5 over 32. This one negative 1 over 4. This one 1 over 4. And this one 1 over 4. So you get the inverse of A here equal to this matrix. Okay, we try to solve exercise page number 60. Alright, so you are given the system of linear equation here. Okay, so first one, the question asks you to write the above system in metric form. So that means we need to write in this form. AX equal to B. So what is A here? Coefficient matrix. So you take all the coefficient for X, for Y, and for Z. So what you will have here? 2, negative 17, 11, negative 1, 11, negative 7. This one will be 0. This one will be 3. And this one will be negative 2. So what is our X here? X, Y, X, Y, Z. X, Y, Z. And what is B here? 1, negative 1, 3. That's how you answer the question number 1. Question 2 here. Find the matrix cofactor of A. That means you need to find the cofactor of A here. So cofactor of A equal to C11, C1, 2, C1, 3, C21, C22, C23, C31, C32, C33. Right, so where is our matrix A? This one. This is our matrix A. Then you need to find the cofactor of this matrix. Alright, so we find C11 first. Negative 1 power 2. And then we find the minor M11. So negative 1 power 2 equal to 1. And M11, this matrix A here. So you delete first row, first column. So what you will have here? 11, negative 7, 3, negative 2. And then you solve for this one. 1, this one, 11, multiply with negative 2, minus negative 7, multiply with 3. So you solve for this one. So 11 multiply with negative 2, negative 22, plus 7 multiplied with 3, 21. So 1, negative 2 plus 21, negative 1. So what you will have here, 1 multiplied with negative 1, negative 1. Next, C12. So negative 1 power of 3 M12 equal to, this one will be negative 1 M12. So you delete first row, second column. So you will get here negative 1, negative 7, 0, negative 2. So this one negative 1. And then you compute the determinant for 2 by 2 matrix here. So negative 1 multiply with negative 2 minus negative 7 multiply with 0. So this one will be negative 1. So what you will have here? Negative 1 multiply with negative 2, 2. Negative, negative, positive. 7 multiply with 0, you will get 0. So negative 1. 2 plus 0 is 2. So negative 1 multiply with 2, you will get here negative 2. Next, we find C13. So negative 1 power 4 M13. So negative 1 power 4 is 1. M13. So we delete first row, third column. So negative 1, 11, 0, 3. So we solve this one will be 1. And for this one, negative 1 multiply with 3 minus 11 multiply with 0. So we compute this one. So negative 1 multiply with 3, you will get here negative 3 minus 11 multiply with 0 is 0. So this one 1, negative 3 minus 0, negative 3. So then you multiply 1 with negative 3, you will get here negative 3. Next one is C21. So negative 1 power 3 and 21. So negative 1 power 3 will be negative 1 and 21. So you delete second row, first column. So second row, first column. So you will left with this one. 3, negative 2. So then we compute this one. So negative 17 multiply with negative 2 minus 11 multiply with 3. So this one will be negative 1. This one will be 17. Negative, negative will be positive. So this one will be 34 minus 33. So this one negative 1. 34 minus 33, you will get here 1. So negative 1 multiply with 1, you will get here negative 1. Next one, we compute C22. So negative 1 power 4 M22. So negative 1 power 4, you will get here 1. M22, that means you delete second row, second column. So second row, second column. So you only left with 2, 11, 0, negative 2. Then we compute for this one. So 2 here multiply with negative 2 minus 11 here multiply with 0. So 1, 2 multiply with negative 2, you will get here negative 4 minus 0. So negative 4 minus 0, negative 4. 1 multiplied with negative 4, you will get here negative 4. Right, next we compute C2, 3. So negative 1 power 2 plus 3, 5, and 2, 3. So negative 1 power 5, negative 1, m2, 3. You delete second row, third column. Second row, third column. So you will have here 2, negative 17, 0, 3. And then we solve for this one as usual. So what you will have here, this one 2 multiplied with 3 minus negative 17 multiplied with 0. So you will have here this one negative 1, 2 multiplied with 3, 6, plus 70 multiplied with 0, 0. So negative 1, so 6 plus 0, you will get here 6. And then what you will get here, negative 6. Okay, we compute C31. So negative 1 power 4 and 31 equal to negative 1 power 4, 1, m31, third row, first column. So negative 17, 11, 11, negative 7. So we solve for this one. So this one 11, 1, sorry. So negative 70 multiplied with negative 7 minus 11 multiplied with 11. So we solve for this one. This one will be 1. So negative 17 multiplied with 7, you will get here 190 minus 11 multiplied with 11, you will get here 121. So we solve for this one. And this one, what you will have here? Negative. So 119 minus this one, you will get here negative 2. And then you will get, the answer will be negative 2. Next, find C32. So negative 1 power 5 m32. So negative 1 power 5 will be negative 1 m32. So you delete third row, second column. So you will get here 2, 11, negative 1, negative 7. Then we compute this one, negative 1. This one 2 multiply with negative 7 minus 11 multiply with negative 1. So then we solve for this one. So this one negative 14 plus 11. So negative 1 multiply with negative 3. So negative 1 multiply with negative 3, you will get here 3. Okay, the last one, we compute C33. So negative 1 power 6 m33. So negative 1 power 6 will be 1. M33 here, okay, you refer the coefficient matrix A here, so you delete third row, third column. So what you will have here? 2, negative 17, negative 1, 11. So we solve for this one. So 2 multiply with 11 minus negative 17 multiply with negative 1. So what you will get here? So 22 minus 17. So 22 minus 17, what you will get? 5, right? So 1 multiply with 5, you will get here 5. Okay, after you get all the C11, C12 up to C33 here, and then you can write the answer for the cofactor of matrix A. So cofactor of matrix A, so you substitute all the value for C11, C12, C13 until C33 here. So C11, negative 1, C12, negative 2, C13, negative 3, C21, negative 1, C22, negative 4, C23, negative 6, C31, negative 2, C32, 3, and C33, 5. So then, you solve for the question number 2 here. Find the matrix cofactor of A. The third question asks you to find determinant of A using cofactor expansion along the first column. So, we must follow the question here. So, the determinant of A, okay, if we use cofactor expansion using first column, along the first column, then the formula will be A11, C11 plus A21, C21 plus A31, C31. So, you can get A and also the value of C here from the previous question. Alright, so A11, okay, remember you take from the coefficient matrix A here. So, A11 will be 2. And C11 will be negative 1. Plus A21, negative 1. C21, negative 1. A31, okay, you see here, 0. C31, negative 2. And then you can compute the determinant here. This one will be negative 2 plus 1 and plus 0 here. So, negative 2 plus 1. So, you get the determinant of A equal to negative 1. Question number 4, the question asks you to find the inverse of A using the adjoint method. So, the formula here will be 1 over determinant of A multiply with the adjoint of A. So, the determinant of A equal to negative 1. And the adjoint of A will be cofactor of A from the question number 2 and then we transpose it. So 1 over negative 1, you will get here negative 1. So the cofactor of A, you can get from the question number 2 just now. This one. So negative 1, negative 2, negative 3, negative 1, negative 4, negative 6, negative 2, 3, 5, and then transpose it. So we transpose this matrix first. Remember, you interchange rows become columns. So negative 1, negative 2, negative 3, second row becomes second column. And third row become third column. Last one, you multiply negative 1 with all the elements in this matrix. So you will have here 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. So this one will be the answer for the inverse of A. Okay, last question, question number 5. Okay, you need to solve the system here using the inversion method. So you need to remember the formula for the inversion method. So remember, inversion method, one of the formula you use to solve for the system of linear equation. So the formula will be x bar here equal to A inverse, you multiply with the B. So what is our x here? X, Y, Z. So X, Y, Z here. And then what is our A inverse? You can get from the question number 4 just now. You solve to find the A inverse. So this one will be your A inverse. So A inverse here, 1, 1, 2, 2, 4, negative 3, 3, 6, negative 5. And then you multiply with B. So what is our B? Our B will be this matrix here. 1, negative 1, 3. Right? So the next step, you just do the matrix multiplication for these two matrices here. So how you do it? Okay, remember you multiply row with column. So for the first row, 1 multiply with 1 plus 1 multiply with negative 1 plus 2 multiply with 3. Okay, for the second row, you multiply with this column. So 2 multiply with 1 plus 4 multiply with negative 1 plus negative 3 multiply with 3. Okay, for the third row, so same thing, row here you multiply with this column. So 3 multiply with 1 plus 6 multiply with negative 1 plus negative 5 multiply with 3. Okay, so we solve this one. So 1 minus 1 plus 6. This one, 2 minus 4 minus 9, 3 minus 6 minus 15. Then we solve this one to get the value of x, y, z. So 1 minus 1 is 0 plus 6, you will get here 6. 2 minus 4, negative 2 minus 9, negative 11. So 3 minus 6, you will get here negative 3 minus 15, you will get here negative 18. So the value of x here is 6, y negative 11, z negative 18. As your practice, please do homework 3.2, page number 61. Try to solve all the questions in homework 3.2. That's all. Good luck.